Hey guys, you are watching Simple Civil with Smriti Gupta, that is me. So, in this video, we will be solving this question by moment distribution method, and this has previously come in Kerala University exam. I have taken this question from that paper. So, how we will understand that the given question is a sway or a non-sway frame? So, there are certain things you should always remember while going for sway or a non-sway frame. So, first is your geometry of the structure, second is your supports, then your loading, then your rigidity. Then based on all these you can understand that your structure is a sway or a non-sway. So this question I have discussed it with many people. Many were saying sway, many were saying that this one is a non-sway, but see, in this question there is a unsymmetrical geometry of the structure. The supports are fixed and we have a symmetrical loading, but because of the unsymmetrical tree we are going for a sway frame. Let's understand this better with a small example which I am putting here. So this is a kind of frame I am setting up for you. So this is a kind of similar what we are going to use. So this is the frame and loading is there. So this is fixed from the bottom. You can assume that this frame is fixed from the bottom. So if the load is coming, either legs could go like this, or the horizontal, if story movement is there, the structure will go somewhat like this. So as you can see, the structure is moving to the right side. So in this question we can assume, okay, the structure could go right side and the legs could go like this. So your intermediate joints will behave as a rigid joint, and you can see that this joint is behaving as one. There is no relative translation, but the joint itself is moving in one in the same fashion. So whatever rotations are coming on to one joint, it will behave as same as one joint. Before moving ahead, we should know that how to analyze a sway frame. So sway frame, we have to do the analysis for the two times. For sway, we have to first analyze the frame with the loading, that is how we do for the non-sway frames. And the second part, we will be analyzing the frame just no loading and with the geometry which is adding up for the sway. So your step number one is your fixed end moments. So first we'll be denoting our joints. So we'll be putting our ABCD onto the frame, and then the second one is for this kind of loading we have a ready-made formula. So on the legs there are no loads, just on the story, that is on BC, we have a loading. So for that we have a ready-made formula with us, that is 2PL/9, where P represents your load, that is 75. So now your question could be why we are putting BC as positive and CB as negative. Here we have just substituted the value of P and L, and we have find out the final value of MBC and MCB. Now why we have taken positive and negative? So in this question what we are considering is, if a load is coming, this is how our beam will be deflected. So there will be a moments which are generated from the support to resist this kind of deflection. So left side, this kind of moment will be generated. This is your anti-clockwise and we are considering at positive. Right side clockwise we are considering as negative. So that's why we have taken our FEM positive negative. Now at this side positive, this side negative, and this is the common joint what is connected from the leg and the story. C is the common joint for leg and the story. So we'll be considering now RF and DF. For that we have to make a table. In this table we'll be writing joint members which are connected to that joint, then RF, sum and DF. Now why we are calculating this RF and DF? So you can see the link which is coming up. You can know or understand why we are calculating RF and DF. So distribution factor is a factor which decides which member of the structure will take how much amount of undistributed moment. Undistributed moment which is coming at a joint and which is not making it to neutral. Additional joint we have to distribute it to the different members which are attached to that particular joint. So it depends on rigidity, length and the kind of support we are having. So these factors decide our RF and our TF. Let's understand this. If we have a fixed joint or a fixed and a hinge kind of joint and a moment is applied onto the fixed end, the amount of resistance or the amount of resistive forces, resistive moments occurred at the other end will be equal to your 4EI by L in the case of fixed and 3EI by L in the case of fixed and hinge. We will be using these formulas. In this question, we have to check our EI values for the beam and the length and we'll be substituting this. So in this one we have all the supports as fixed supports. So we'll be using 4EI by L and here I am writing. So your BA is 6 and EI is 1. Your BC length is 3 and it is twice I. Same your CB length is 3 and EI is 2I. Here it is 4 and I. So I have written all the EI and length so that chances of mistakes are less. I'll be just simply substituting these values in the calculator and I'll be finding out the value of RF and DF. So here we are summing up and next is we'll be finding out the DF. So DF is your RF divided by the sum of RF and we have to always remember that the sum has to be equal to 1. At one joint, the number of members attached to that joint will give total sum of DF as 1. So next we are moving on. We have calculated our FEM and we'll be using these values in the moment distribution table. So we have to make a table like this and we'll be using these values. We'll be substituting these values in the table. Along with that, we have to remember that which joint is fixed and which joint is a hinge in this question. All the joints will behave as a fixed joint because your intermediate joints, that is B and C, will behave as a fixed joint and rest A, D are given as fixed. So all will be behaving as fixed joint. So here we are with the table and what we'll be doing is we'll be just writing down the value of DF what we have calculated and the value of FEM what we have calculated. So I am just simply writing the values here what we have calculated before and the FEM what we got, I'll be just writing it like this. Now at B support 50 is the unbalanced moment what we got. At C support minus 50 is the unbalanced moment what we got. What I am going to do is we will be balancing these undistributed moment onto the members which are attached or joined to that particular joint. So what we'll be doing, putting a opposite sign. If we have to balance it, we have to put the opposite sign, then just multiply the value of DF in it and write it down. So opposite sign multiply by DF and just write it down. Next is we'll be distributing it to the nearest member. So we have to just distribute it half of the amount with the same sign. The students what they do mistake is they change the sign. While distributing the moment, they change the sign. So this is the common mistake what students do. So we have to distribute half of the amount with the same sign to the nearby fixed member. The amount will be half with the sign and to the nearby fixed member only. At hinges or rollers, we don't distribute any moment, only to the fixed members. Next step is at B support we have positive 18 point this much unbalanced moment. And at C we have minus 20 unbalanced moment. Again what we will be doing? We will be balancing the moment. So opposite sign we have to put, then multiply by the DF, and again we will be multiplying it, writing it, and then distributing it. Here we are, we have just multiplied by the DF and we are writing, that is opposite sign multiplied by DF, and we are writing. Now we will be distributing it onto the fixed joint what we are having. Neighboring fixed joint with the sign divided by 2 with the sign, we have to just simply distribute it to the neighboring joint. Now, so after this what we have to do? Wind. I'm using the natural light actually, so wind came, sorry for that. We have to write this carryover. Wherever we are distributing it, we have to write carryover. Wherever we are balancing it, wherever we are multiplying it with the DF, we have to write out the balancing. So I have just written balancing carryover. Alternatively, what we have to do next is we have to write opposite sign. This is positive, this is negative. I am writing opposite sign and I am just multiplying it with the DF and I am writing it down. So you have to do is multiply it with the DF and write it down. Here we are. So here we have just multiplied, and now the next thing is I'll be distributing it to the neighboring joint. So half of it with the sign, always remember half of it with the sign we have to distribute it. So here we are, we have just did the 3 iterations. We have to do at least 4 to 5 iterations to get the best results. So just simply again balance it. Here we are. So this one is positive, I am writing negative, positive, multiplied with the DF and just write it down. Multiplied with the DF and write it down. Just simply multiply it and write it down. The next step is we'll be distributing it to the next member, joint. So half of it with the same sign. Do not do mistake. Most of you do this mistake. Next is your balancing. I guess this would be the last cycle. We have already did the 4 iterations and would be the last cycle what we are doing. Just opposite sign, multiply it with the DF and write it down. Now after this we have to add all the moments what came at a joint. So when you are adding all, we have to remember at a joint the moment should come negative, positive, and it should neutralize a joint. So we have to simply, after this we will be finding out the horizontal forces because of these moments. So these are the moments which are on A and B leg. So this is negative, that is clockwise. So I am putting a clockwise moment and I am writing down the moments what came. And with these we will be finding out the horizontal forces acting onto the legs of the structure because of this. So I am just simply writing down all the moments what came, and I am just simply finding out. Here we are, I have written this. Now these are the horizontal forces which are acting onto the column, and this is a sway which is acting onto the story. So this is acting onto the story. So this is your 6 and this one is your 4. It is given in the question. We have to find out the moment at B point. So at this point, we will be finding out the moment. So HA, it is going in the clockwise direction, so negative it is. So this one into the perpendicular distance is your 6. So this one, and we will be taking both the moments. Since both the moments are negative, we are going to write it in the same manner what we have calculated in the table. So here we are. I am writing down all the moments equal to 0, and here just put it in the calculator and you will get the value of HA. We came out to be negative. Now for this is clockwise, so negative, and these two are anti-clockwise, so positive we are putting, and we are simply putting it in the calculator and finding out the value of HD. Now Using these two values, we will be finding out the value of the sway. So this is your x. Just sum up these two forces to find out the value of x. So HA plus HT is equal to this much. So this is our sway forces acting because of loading. Next, we will be finding out what is the contribution of the geometry of the structure onto the sway forces. So we will be finding out the forces which are generated because of the geometry of the structure. For this, we will be taking this example. If this is a beam and one end is sinking down, so these kind of moments will be generated. So for example, this is a fixed beam. Here we are. So this is a fixed beam and one end is sinking down by delta, let's suppose. So the amount of moment which are generated here is 6 EI delta by L square. So left side is positive, right side is also positive because both are anti-clockwise. Right side is because it is generated because of the sinking. Left side moment is opposing this deflection which is occurring. So same thing we will be applying it onto our structure. So I am making this structure and we are assuming this story is deflected by this much amount, that is delta amount. So our legs will go somewhat like this since it is fixed from the base. So no much deflection or variation will come near the support, and this story will deflect in delta. So this is how it will be generated. Now these are the moments which are developed. So your top moments is because of the shifting and bottom moments, these are resisting the deflection. So the value is 6 CI by delta by L square. So these are the moments what we are going to use for the non-sway analysis. So we will be writing 6 EI delta by L square. Let's understand this more. So this is our structure and it is deflected somewhat like this. I am just pushing onto the story and the deflection is coming like this. So the moments which are generated are like this. Onto the top, the moments will generate like this. So this is how our structure will look like when we are giving a horizontal forces onto the structure. Now again we have to do one more analysis. Stay with me. So here we are. This is our frame. This is the length what it is given and these are the moments. Fast we'll be calculating the moments and then we'll be analyzing the sway frame. So here we are. Your AB is 6 EI delta by L square. So here we have to just simply substitute the value of length and EI. So in this case, I and I are given for the legs, for the vertical members, but no value of delta and EI is given. So what we have to do is, we have to first simply substitute the value of the length onto the formula. Then we have to make one assumption. This assumption is, we can take any value of EI delta. So we can take any value. In this question, I have taken EI delta as 60. So I am substituting this EI delta in the moments which is here and I am putting these values into the table, back into the table, and again we have to analyze it. So these are the moments what we are going to use. So again we have to make that table. We'll be using the same DF what we have calculated. DF will not change because it is not a loading property, it is a geometrical property. We'll be using the same FEM what we got and then we have to again repeat the same procedure. Opposite sign, multiply by DF and write it down. Opposite sign, multiply by DF and write it down and then shift it to the nearby support. With the sign divided by 2. With the sign divided by 2. So this was your balancing and this is your carryover. Again repeat the procedure. Opposite sign, multiply by DF, write it down. Opposite sign, multiply by DF, write it down. Then write it down then just shift it to the nearby support, what we have done earlier. Divided by 2 with the same sign, divided by 2 with the same sign, and this is all carryover which we are carry over to the next joint. So opposite sign multiplied by the DF, and we have to write it down. Opposite sign multiplied by the DF, and we have to write it down. Here we are. So I am just multiplying it and I am writing it down. Shift it to the nearby support. Here we are. Shift it to the nearby support, half of it with the same sign. Half of it with the same sign we have to write, and this is all carryover. We are distributing it onto the other joint. Here we are. So again we have to go for 4 to 5 iterations, 4 to 5 cycle we have to repeat, then only our answers will come correct. So at a joint we have to always remember that your left side and right side moments has to be equal and opposite, then only our question will be correct. If it is not coming, you go for one more iteration. So after 3 or 4 iterations you can check at one joint. If the answers are not coming correct, you can go for one more iteration, one more distribution, one more balancing you can do. So like that you can proceed, and you can check with steps. You can check like we have done with the 4 iterations. Now this is the time we can find out our final moments. So what we have to do, just sum up all the moments. So see, it is coming opposite, equal and opposite. So at C also it is coming equal and opposite. So we are going on to the next step. Our next step, like this, we are making, again we are using those moments, and we are now calculating the forces which are generated because of the geometry. So these are the moments what we are using, and we'll be again finding out HA and HD. So this is coming out to be clockwise, so negative I am taking, and whatever moments are generated with the sign you take and calculate the value of HA and HD. So here we are, just simply substitute these values into the calculator and find out the value. So your HA comes out to be this much. Similarly your HD, if we are taking the moment, it is also coming out to be clockwise, so this is also negative. So like what we have done left side, same thing we have to do right side. We have to take the moments and then calculate the value of X dash, that is the sway force because of the geometry of the structure. So this is your X dash. We have to just simply sum up these two and we will be finding out the final value. Now our next step is we will be finding out our final X, that is, this is a factor which we will be multiplying it into the sway analysis, because sway analysis we have done one assumption that was based on some assumption. So we will be multiplying this factor so that our answers should be near to the reality. So this is the factor what we are going to multiply it in the moments to find out what is the final answer. So here we are. What now we have to do? We have to look for the moments what we got from the loaded frame, and then we have to check for the non-loaded frame, and we have to multiply the factor in the non-loaded analysis, because that was based on the assumption what we have done. So we have to just simply sum up these two moments and we can get our final answers. Okay, wind came, sorry for that. Okay, here we are. So I am just simply writing down all the moments what we came from the loaded and non-loaded structure, and I am just simply writing it down. So in sway analysis we have to analyze our frame in 2 parts. हमें 2 पार्ट में अपने फ्रेम को एनालाइज करना होता है, एक हम लोडेड में करते हैं और एक हम करते हैं नॉन लोडेड में. तो हमें अपने फ्रेम को एक्चुअली में 2 बार एनालाइज करना पड़ता है. अगर आपको मेरा वीडियो अच्छा लगा और आप और ऐसे वीडियोस देखना चाहते हैं, आप प्लीज़ कमेंट्स में लिखकर बताइए कि आपको मेरा वीडियो कैसा लगा, या आप चाहते हैं कि मैं आपकी पसंद का कोई वीडियो बनाऊं. Please write it in the comment section and please subscribe my channel. Thank you for watching.